These definition based problems where we said that the 2 is the only even prime, odd plus odd is even. This is the first question we discussed yesterday. These also we discussed how to check whether a number is a prime or composite using a power n minus b power n concept. Second question we discussed yesterday. Just a few minutes of recap. Again, how to check whether a number is a prime number or not with a different concept. How to take all the prime numbers less than root 10 and check. This is another concept we discussed yesterday. Again, one more concept we discussed. How to check whether a number is a prime number or a composite number using a power n plus b power n concept. A power n plus b power n is divisible by a plus b if n is odd. This is the concept we discussed. Then same similar question. A power n plus b power n concept. We used this and we got the answer as composite number. Concept used is a power n plus b power n is divisible by a plus b if n is odd. Fifth question we discussed. Again, if the number of digits in a number are more, if the number of digits in a number are more, if the number of digits in a number are more, how to check whether the number is a prime or composite? Sixth question also we discussed yesterday. Kindly do not miss any questions. Prime or a composite. How to find out the last two digits? Excellent question. In this question yesterday we discussed the divisibility rule for 5 we discussed, 3 we discussed, and also we used a power n plus b power n concept. We got the answer yesterday as 1. These eliminated. Students who missed the yesterday's session, right? In this question we discussed the divisibility rule for 101. And we got the answer as 101. Take a group of 2 digits. Students who missed yesterday's class, again we used the concept of a power n plus or minus b power n, and we got the answer it as 999,983. Students who missed the yesterday's session 1, then we got the answer as p1 equivalent to 2 based upon the concept of smallest even number which is a prime number. We got the answer. 10th question also we discussed yesterday. Next one, same logic. We discussed. Next, these also we discussed yesterday, where 51 factorial plus 1 is the original number. If I do p plus 1, this will become 51 factorial plus 2. This is an even number and this is an even number. Even plus even, this will be divisible by 2. Similarly, p plus 50, this will become 51 factorial plus 51. This is divisible by 3, divisible by 3. Answer will be divisible by 3. 12th question yesterday we discussed. Same concept we used it and we got the answer as 0, where p ranges from this value to this value. So p is 1999 factorial plus 1. Next natural number is plus 2. This is 1999 factorial plus 3, and it is 1999 factorial plus 1998. So these contains 2. Even plus even is, this will become an even number. This contains 3. If I add 2 numbers which are divisible by 3, answer will be divisible by 3. This is an even number. This is an even number. So answer will be divisible by an even number. Answer is 0. Till 13th question we discussed. Yesterday we discussed the first 13 questions. Now what we will do is, we'll start from the 14th question. Students who missed the yesterday's session 1, just I repeated what all we discussed it. Now we will start the class. Right, 14th question. Listen carefully, sir. Very, very good question. First we will understand the question. N is nothing but P plus X. This is the first step. N is nothing but P plus X. Okay. P is nothing but the product of all prime numbers less than or equivalent to 31. P is nothing but the product of all prime numbers less than or equivalent to 31. 2, 3, 5, 7, 11, 13 and so on up to 31. Okay. Second point also it is clear. X lies in the range 2 to 29. X could be any natural number from 2 to 29. X could be 2, X could be 3, X could be 4, X could be 5. All are natural numbers. So it is till 29. For what values of X is N prime number? For what values of X is N prime number? Okay. For what values of X, N will be a prime number. So the first thing is, for N to be a prime number, this N should be a prime number. For N to be a prime number, which all values X can take? This is the question. For N to be a prime number, which all values X will take? So N is nothing but P is the product of all prime numbers. Product of all prime numbers will be 2, 3, 5, 7 and so on up to 31. Okay. X is nothing but either 2 or 3 or 4 or 5 and so on up to 29. For what values of X is N prime number? Now if you observe closely, this is a very, very good question, sir. 2 into any number multiplied by 2, it becomes an even number. If I take the first value of X, which is 2, 2 is again an even number. 2 is again an even number. So any number multiplied by 2, it is an even number. Plus 2 is an even number. Even plus even, it will become an even number. Is there any even number other than 2 which is a prime number? No. So that means for X value 2, N cannot be a prime number. And next observation, suppose if I take 2 into 3 into 5 into 7, this entire number is multiplied by 3. That means P is nothing but it is a multiple of 3. P is nothing but it is a multiple of 3. Here X if I take 3, again this is divisible by 3. 3 is again divisible by 3. So this entire P is multiple of 3. X is also divisible by 3. If I add two numbers which are divisible by 3, answer will be divisible by 3. That means for 3 also it is not possible. Again 2 into any number is even. Next case 4. 4 is nothing but an even number. Even plus even is an even number. Even number other than 2, there cannot be any number which is a prime number. 4 is out. This number is divisible by 5. Next 5. 5 is divisible by 5. If I add two numbers which are divisible by 5, answer will be divisible by 5. So on and so forth. Every value of X, whatever I takes, every value of X, whatever I am taking, that is coming under a part of this one. If I take 2, 2 is present here. If I take 3, 3 is present here. If I take 4, the factor of 4, 2 is present here. If I take 5, 5 is present here. If I take 29, 29 is present in P. That means for every value of X, either its factor is present in P or the original number is present in P. So none of them will be a no value of X. There exists no value of X such that N is a prime number. Excellent, very, very good quality question which helps you to understand the definition of a prime number. I hope the concept is clear. Second time I am repeating it. there is an equation n equivalent to p plus x, where p is the product of all prime numbers from 2 to 31. So I wrote 2 into 3 into 5 into 7 till 31. X is a natural number from 2 to 29. N is p plus x. So 2 into 3 into 5 into 7 till 31. If I take x, 2 value, 2 into any number even, 2 is an even number. If I add 2 even numbers, answer will be an even number. 2 into 3 into 5 into 7, these is divisible by 3. Plus 3, if I take 3 is also divisible by 3. If I add any two numbers which are divisible by 3, answer will be divisible by 3. There cannot be any number other than 3 which is divisible by 3, which is a prime number. And the process continues. If x is 29, 29 into something is nothing but p. If I add two numbers which are divisible by 29, answer will be divisible by 29. Answer is, there exists no value of p. There exists no value of x which makes n a prime number. Put a star mark on this question. Excellent question, sir. Very, very good quality question. 14th question. I hope it is very, very clear to each one of you. 15th question. I hope it is clear, right? 15th question. Now 15th question. P plus 2, P plus 4 are prime numbers. How many prime values P can take? He is asking. P plus 2, P plus 4 are prime numbers. How many prime values P can take? First we will write down the concept. Every prime number greater than 3. Every prime number greater than 3 is of the form 6k plus or minus 1. This concept I am going to use it. Every prime number greater than 3, it is of the form 6k plus or minus 1. He is asking a triplet. What is the triplet? P plus 2, P plus 4. He is asking P plus 2, P plus 4. P plus 2, P plus 4 are prime numbers. How many prime values P can take? How many prime numbers P can be attached to? How many prime numbers P can be attached to? So the lowest prime number is 2. 2 plus 2 is 4. 2 plus 4 is 6. 2, 4, 6. 4 is a composite number. 6 is a composite number. So this is not possible. Next prime number is 3. 3 plus 2, 5. 3 plus 4, 7. 3, 5, 7. This is a prime triplet. All the 3. 3, 5, 7. All the 3 are prime numbers. That is what we require. P should be a prime number. P plus 2 should be a prime number. P plus 4 also should be a prime number. Now there is a concept. Every prime number greater than 3 is of the form 6k plus or minus 1. Every prime number greater than 3 is of the form 6k plus or minus 1. If it is 6k plus 1, any prime number greater than 3, it should be of the form 6k plus 1 or 6k minus 1. If I take it as 6k plus 1, 6k plus 1 plus 2, 6k plus 3. 6k plus 3 is nothing but, if you observe closely, this is divisible by 3, 3 is divisible by 3. If I add two numbers which are divisible by 3, answer also will be divisible by 3. Answer also will be divisible by 3. So 6k plus 1 plus 4, 6k plus 5. This entire p plus 2 value is of the form 6k plus 3. That makes it divisible by 3. Any number divisible by 3 is a composite number other than 3. So, but we require triplet to be a prime number. So 6k plus 1 is not valid. Suppose if I take 6k minus 1. If I take 6k minus 1, 6k minus 1 plus 2, it is 6k plus 1. 6k minus 1 plus 4, it is 6k plus 3. Again we are getting 6k plus 3. 6k plus 3 means this is divisible by 3 and it is divisible by 3. If I add two numbers which are divisible by 3, answer should be divisible by 3. That means p plus 4 is becoming divisible by 3 if p is of the form 6k minus 1. So these also not possible. Why? Because all the 3 should be a prime number. Any number which is divisible by 3 other than 3, it is a composite number. Here it is becoming composite, here becoming composite. So the only value where all the 3 are prime number is p is taking 3. 3 is making it 3, 3 plus 2, 3 plus 4. So answer is, how many prime values p can take? Only one prime value p can take. Only one prime value p can take. Only one prime value p can take. And the value of p is 3. Very, very good question. This question uses the concept. Every prime number greater than 3 is of the form 6k plus or minus 1. Every prime number greater than 3, it is of the form 6k plus or minus 1. I hope the idea is clear. Kindly reply it in the live chat if the idea is clear. Kindly reply it. Maximum number of questions we will solve it in the class. Sequential order, concept by concept, application of concept via problem solving. I hope it is clear. Kindly reply it in the live chat if it is clear to you. Is it clear to you? P plus 2, p plus 4 are prime numbers. How many prime values p can take? I started with 2, then 3. Every prime number greater than 3 should be of the form 6k plus or minus 1. 6k plus or minus 1. I want all the viewers who are watching it to kindly reply it in the live chat if it is clear to you. P plus 2, p plus 4 are prime numbers. Absolute conceptual clarity. Same model. P plus 14, p plus 26 are prime numbers. How many prime values p can take? P plus 14, p plus 26 are prime numbers. How many prime values p can take? So there is p, and there is p plus 14, and there is p plus 26. P plus 14, p plus 26. How many prime values p can take? P has to take the prime values. Lowest prime number possible is 2. 2 plus 4 is 16. 2 plus 26 is 28. 16 or 28 are composite numbers. So 2, 16, 28 it is out. Next is 3. 3 plus 14, 17. 3 plus 26, 29. Yes, 3, 17, 29. All the 3 are prime numbers. One case it is possible. Every prime number greater than 3, it should be of the form 6k plus 1 or 6k minus 1. If I take 6k plus 1, 6k plus 1 plus 14 is 6k plus 15. 6k plus 1 plus 26 is 6k plus 27. Just now we discussed 6k plus 15. This is divisible by 3. 15 is divisible by 3. If I add two numbers which are divisible by 3, answer should be divisible by 3. There is no number other than 3 which is divisible by 3. So this case is eliminated. Every prime number greater than 3 is of the form 6k plus 1 or 6k minus 1. If I take 6k minus 1, 6k minus 1, 6k minus 1 plus 14 is 6k plus 13. 6k plus 13. This 6k plus 13 can be written as 6 into k plus 2 plus 1. K plus 2, if I give it to a different variable, this is nothing but 6a plus 1. So I am replacing k plus 2 with a. So this is nothing but 6a plus 1. Similarly, 6k minus 1 plus 26 is 6k plus 25. 6k plus 25 is nothing but 6 into k plus 4 plus 1. So k plus 4 I will give it as some variable b. That means here if I take 6k minus 1, 6k minus 1, I got 3 cases. What are the 3 cases? One is 6k minus 1, One is 6a plus 1, another is 6b plus 1. Now we have to check, are there any prime numbers which are of the form 6k minus 1 which will make these three prime numbers. For example, if I take 17, 17 is nothing but 6 into 3 minus 1. Yes, 17. 17 plus 14 is 31. 17 plus 26 is 43. Suppose if I take, suppose for example, 83. 83. 83 is 6 into 14 minus 1. 83 plus 14 is 97. 83 plus 27, 26 is 109. 83, 97 and 109. These are also a prime number. Not if I take 6k minus 1, I just picked a few numbers. Suppose if I take, for example, 23. 23 is of the form 6 into 4 minus 1. But 23 is making 23 plus 14, 37. 23 plus 26, 49. But 49 is divisible by 7. That means out of so many numbers which are of the form 6k minus 1, there may exist few numbers which actually make the triplet a prime number. That few numbers could be 17, 83, so on and so forth. There might exist few numbers which does not make the triplet to be a prime number. So in a 2-digit number, there could be few numbers. In a 3-digit number, there could be few numbers. In a 4-digit number, there could be few numbers. We do not know where the prime number will end. In 2-digit, there will be few. In 3-digit, there will be few. In 4 digits, there will be few. In 5 digits, there will be few. And the process continues. So total here I might get infinite numbers plus 1. Answer is nothing but countable infinite. We can count it, but you have better things to do in life. Answer for this question is countably infinite numbers. Countable infinite numbers. Out of numbers which are of the form 6k minus 1, there exists few 2-digit numbers. In 3 digits also there might exist. 4 digits also there might exist. 5 digits also there might exist. There might exist many numbers plus 1. Answer is countable infinite. I hope the idea is clear. In the previous question, we got only one triplet because 6k minus 1, 6k plus 1 is one of the number happens to be divisible by 3. But here, if I take 6k minus 1, now by the time you got 6a plus 1, you could have realized there could be a possibility. And we proved it that there are some possibilities by taking few examples like 17 and 83. So answer for this question is countable infinite. Based upon every prime number, what is the concept that I used in this question? Every prime number greater than 3, it is of the form 6k plus or minus 1. This is the concept which I used it. Every prime number greater than 3, which is of the form 6k plus or minus 1. Yesterday I wrote the statement. Today I applied it in problems to check how many triplets are prime numbers. 2 questions. I am sure it is clear to you. Every prime number greater than 3, it is of the form 6k plus or minus 1. Now let me go to the next question. This question is from permutation and combination. This question is based on counting principle. Very tricky question. Counting principle. Now before solving any question, what we will do is first we will understand the question. How many 9-digit numbers? He is asking how many 9-digit numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How many 9-digit numbers? This is the first keyword for me. That can be formed using the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally from 1 to 9, there are 9 digits are there. Okay, 9 digits should be kept in each and every place. Oh, one important point, repetition not allowed. Okay, no digit should be repeated. That means if I keep 1 in the unit digit, 1 cannot be kept in the any other place. If I keep 8 in the tens place, in all the other 9 places, 8 cannot be kept. That is the meaning. How many 9-digit numbers are prime numbers? Prime numbers. How many 9-digit numbers are prime? Very, very tricky question. Listen carefully the way I solve. First, this place I am filling. This place can be filled in 9 ways. And the 9 way is, because I did not fill up any place, you can keep any digit from 1 to 9 in this leftmost place. From 1 to 9 in the leftmost place, any place you can keep it. Any place you can keep it. So it is 9. Because the repetition is not allowed, one digit is already kept in the leftmost place. Here I can keep 8 digits. Because I already kept 2 digits in the leftmost, I can keep 7 digits. I can keep 6 digits. I can keep 5 digits, 4 digits, 3 digits, 2 digits, and there will be only 1 digit and there will be only one place. So 9, 8, 7, 6, 5, 4, 3, 2, 1. One event. First I am keeping this place, then I am keeping this place. Then I am keeping this place, then I am keeping this place, then I am keeping this place. And the process continues from 10s to 1. So one event is happening after another event. One event happens after another event. One event happens after other event. If one event is happening after another event, this is nothing but a fundamental principle of multiplication. If one event follows the another event, you have to use one rule under fundamental principle of counting, that is fundamental principle of multiplication. Fundamental principle of multiplication. So this will become 9 into 8 into 7 into 6 and so on up to 1, which is nothing but 9 factorial. Total 9 factorial numbers are there. The question is, out of these 9 factorial numbers, how many numbers are prime numbers? How many numbers are prime numbers? Suppose if I take a random 9-digit number. If I take one number out of a 9 factorial numbers, let me see what is that number. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are random number. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are random number. Now if you look at this number, what is the sum of the digits? Sum of the digits is nothing but 1 plus 2 plus 3 and so on up to 9, which is summation 9. Summation 9 is nothing but 9 plus 9 into 10 by 2, which is 45. Easily you can say it as 45. Why? Because if I look at this question, if I look at these numerical values, 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. Here this 4 with this 4, I will get a summation 10. 10 fours are 40. 40 remaining middle digit is 5. 40 plus 5, 45. Sum of the digits is 45. 45 means it is divisible by 3. 45 means it is divisible by 3. 4 plus 5 is 9. 9 is divisible by 3. Right? 9 is divisible by 3. Because the question is repetition not allowed. Repetition not allowed. If I interchange the digits, 9, 1, 8, 6, 7, 5, 4, 3, 2. All the digits we got 1, 2, 3, 4, 5, 6, 7, 8, 9. If I add all the digits, irrespective of how you are adding 1 plus 2 plus 3 and so on up to 9 or 9 plus 8 plus 7 and so on up to 1, the sum of the digits will always be 45. Even if I change it to 7, 8, 9, 6, 5, 4, 1, 2, 3, still the sum of the digits will be 45. 45 means all are divisible by 3. That means irrespective of the position of the digits, the sum will always be 45. That means total there are 9 factorial numbers. Only the position of the digits will change, but all the 9 factorial number, if I do the sum of the digits, all happens to be 45. 45 means all are divisible by 3. So answer for this question is big 0. Answer for this question is big 0. In 9 factorial numbers, there exists no number which is a prime number. Why there exists no number which is a prime number? for that, because the question is repetition is not allowed. Every digit should be written only once. A digit should not be written more than once. So if I write 1, 2, 3, 4, 5, 6, 7, 8, 9, the sum of the digits is 45. 45 is divisible by 3. That means one number is divisible by 3. If I just understand and change the position of the digits, even if I change the position of the digits, the sum of the digits will not change. All 9 factorial numbers, the sum of the digits will be divisible by 3. Very good question, very tricky question. Most of the students think that it's a difficult question. Once they got 9 factorial, they realize that it's a very time consuming question. But if you apply the divisibility rule of 3 in at least one number, you will realize that all the numbers are actually divisible by 3. All the numbers are actually divisible by 3. Very good question. Very good question. In our class, a lot of conceptual clarity questions we will discuss. By the time the class is over, students should feel that their investment of their personal time in the class has resulted in the growth in the subject. No entertainment, no time pass, nothing. Strict straight on to the subject and only subject. 17th, I hope it is clear. 18th question. Another question. If a square minus b square is 101, the first catch in the question is 101. The right hand side value is a prime number. That is the root cause of the. Anyway, in the next further classes, I will take what happens if the right hand side is an odd number or an even number. Right hand side is a prime number. Right hand side is a prime number. Okay. And we know that prime number will have only two distinct factors. Prime number will have only two distinct factors. And the factors is nothing but 1 and 101 in this case. So now let us solve. What is the question? Question is, if a square minus b square is 101, a comma b belongs to natural numbers, find a square plus b square. Okay. He has given a square minus b square. A square minus b square is 101. This is nothing but a plus b into a minus b is 101 into 1. Mathematically, you should not write 1 into 101. Why? Because if a and b are natural numbers, sum of the two natural numbers will always be greater than their difference. Sum of the two natural numbers will always be greater than difference. A plus b will take 101, a minus b will take 1. If I am taking 1 into 101, you are telling that a plus b is less than a minus b when a and b are natural numbers, which is illogical. So write down it as 101 into 1. You cannot break it. So a plus b has to take 101. A minus b has to take 1. If I add two values, add it. A plus a is 2a. 2a is 102. A value is nothing but 51. If a value is 51, a plus b is 101. A value is 51. 51 plus b is 101. B value will become 50. What is the question he is asking? Find a square plus b square. So this is nothing but 51 square plus 50 square. Those who have listened to my Speed Max classes, 51 square is 2601, 50 square is 2500. So answer for this question is 5101. The idea behind the question is the right hand side is a prime number. Prime number will have only two distinct factors, and the two distinct factors are 101 into 1. 101 into 1. A plus b into a minus b is 101 into 1. A plus b 101, a minus b 1. If I add both the values, I will get a value 51 and b value 50 if I substitute it. Other than right hand side, if it is a, other than prime number, if it is a composite number, how to discuss? That also we will discuss. I hope the idea is clear. Answer is 5101. Simple question where there is a quadratic equation a square minus b square, right hand side is a prime number. Now we are getting into an intermediate level questions. For how many prime values p is p square plus 3p minus 1? Same question we did it. How many prime values of p where p plus 2, p plus 4 are prime numbers? How many prime values of p where p plus 14, p plus 26 are prime numbers? This is one variety. Now I am discussing another variety. Now I am discussing another variety. What is the question? There is an equation p square plus 3p minus 1. This should result in a prime number. The output, that expression should be equated with a prime number. For p square plus 3p minus 1 to be a prime number, how many prime values p can take? Same idea. Let me take the lowest prime number p value 2. If I take p value 2, this will become 2 square plus 3 into 2 minus 1. So these 4 plus 6 minus 1. 10 minus 1 is 9. 9 is a composite number. 9 is a composite number. If I take the next prime number, which is 3, which is 3 square plus 3 into 3 minus 1, which is 9 plus 9 minus 1. 18 minus 1 is 17. 18 minus 1 is 17. 17 is a prime number. Every prime number greater than 3, it is of the form 6k plus 1 or it is 6k minus 1. Another beautiful application of this concept. So if I take 6k plus 1, 6k plus 1 whole square plus 3 into 6k plus 1 minus 1. So which is 36k square plus 12k plus 1 plus 18k plus 3 minus 1. Minus 1 plus 1 cancel. Minus 1 plus 1 cancel. These is divisible by 3, these is divisible by 3, these is divisible by 3 and it is divisible by 3. All are divisible by 3. So answer will be divisible by 3. Answer will be divisible by 3. Plus 1 minus 1 cancel. 36k square plus 12k plus 18k. All are divisible by 3. If it is 6k minus 1, this will become 6k minus 1 whole square plus 3 into 6k minus 1 minus 1. So that 6k minus 1 whole square is 36k square minus 12k plus 1 plus 18k minus 3 minus 1. Plus 1 minus 1 cancel. Divisible by 3, divisible by 3, divisible by 3. 3 is also divisible by 3. That means 6k plus 1, the expression is getting divisible by 3. 6k minus 1 also, the expression is divisible by 3. So only one value, p equivalent to 3, right hand side I am getting a prime number. Only one value. Remaining all the numbers are composite numbers. Remaining all the numbers are composite numbers. Remaining all the numbers are composite numbers. So answer is only one prime value. Only one p value and the p value is 3. I hope the idea is clear. I hope the idea is clear. Whenever the question is check whether the expression is resulting in a prime number or not, use the concept of every prime number greater than 3, it is of the form 6k plus or minus 1. Every prime number greater than 3, it is of the form 6k plus or minus 1. Write down every problem in the same structure whatever I am telling it. Unfortunately, after the class is over, you cannot watch the class again. Only for the enrolled students, these videos will be available apart from 2500 or 3000 videos as a free add-on only to the enrolled students for a particular period of time. I hope it is clear. 19th question, I hope the idea is clear. Now, let us get into the 20th question. What is the concept that is used here? The concept that is used in this question is every prime number greater than 3, it is of the form 6k plus or minus 1. Every prime number greater than 3, it is of the form 6k plus or minus 1. I hope the 19th question idea is clear. 20th question. 20th question. Do not miss any class of mine in case another practice question. Now you can answer this question orally. How many prime numbers P? Same idea. P square plus 15P minus 1 should be a prime number. Should be a prime number. Now if you observe P value is 2. 2 square plus 15 into 2 minus 1, which is 4 plus 30 minus 1, which is 33. 33 is a composite number. P value 3. This will become 3 square plus 15 into 3 minus 1. 9 plus 45 minus 1, which is 53. 53 is a prime number. Every prime number greater than 3, it is 6k plus or minus 1. 6k plus 1 whole square plus 15 into 6k plus 1 minus 1. 6k, you don't need to expand it directly right now because we have done 6k square is divisible by 3. 2 into 6k plus 1 divisible by 3. Divisible by 3, divisible by 3. Plus 1 minus 1. The entire number is divisible by 3. Entire number is divisible by 3. Similarly, if I keep P equivalent to 6k minus 1, this will become 6k minus 1 whole square plus 15 into 6k minus 1 minus 1. 6k square divisible by 6k square divisible by 3. 2 into 6k divisible by 3. Divisible by 3. 15 divisible by 3 plus 1 minus 1. Again it is divisible by 3. Again it is divisible by 3. So answer is, again we got one value where P equivalent to 3. P square plus 15P minus 1. This is becoming value 53. 53 is a prime number. 53 is a prime number. So how many values? Only one prime value P can take. Only one prime value P can take. And the value of prime should be 3. And the value of prime should be 3. 19th and 20th. Same model, sir. If I see 19th question and 20th question. 19th and 20th question, it is of the same model. 19th and 20th, same model. 19th and 20th, they both are of the same model question. I hope this idea is also clear. From prime numbers, you will not get a single doubt, or probably a, sir, this is not covered in the class. Those who are going through a coaching centers, you will realize that what is taught in the classes is basics. What comes in the mocks is a very different high level altogether. Now, we will include basic, intermediate and advanced class, all the kinds of concepts in our online class. Maybe that is the reason maximum number of students from IITs and NITs, they purchase our course because of the kind of content they get it and the kind of results we produced in toughest examinations known as CAT examination. I hope the 20th is clear. 21st. And the best thing is all the classes are taken by me. So that is the best thing. What is the largest prime number? Okay. Whose cube divides 1 factorial into 2 factorial, 1 factorial into 2 factorial into 3 factorial and so on up to 1001 factorial. 1001 factorial. In this number, there is a prime number, it seems P. What is the largest? 1001 is 7 into 11 into 13. 1000 even number not possible. 999, it is divisible by 3, not worthy. 997 is prime number or not. Yesterday we discussed, take the square root of 997. So 31 square is 961. 31 square is 961. So it is closer to 31 point something. Write all the prime numbers less than or equivalent to 31. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Check if 997 gets divided by any of these numbers. 997 is not divisible by 2, 3 not possible, 5 not possible, 7 not possible, 17 5s are 85, 147 not possible, 990 19 5s are 95, 47 not possible, 23 4s are 92, 77 not possible, 29 3s are 87, 127 not possible, 31 3s are 93, 67 not possible, none of them. That means 997 is a prime number. Okay, good. We first understood what is the largest prime number. 997 is a prime number whose cube divides. Now see here. 5 factorial. For example, 5 factorial is 5 into 4 into 3 into 2 into 1. Can I say 5 factorial contains 5 power 1 into k? Are you there with me? 6 factorial. 6 factorial is 6 into 5 power 1 into 4 into 3 into 2 into 1. Can I say the number which is just greater than 5? 6 factorial also contains 5 power 1 into some other number. Are you all with me? With this understanding, let us see. 997 factorial, which is nothing but 997 into 996 and so on up to 1. Can I say this contains 997 power 1 into k1? Are you all with me? 998 factorial. 998 factorial is 998 into 997 and so on up to 1. This also contains 1 into k2. 998 factorial contains 999 factorial. These also contains 997. I hope you are all there with me. 1000 factorial. 1000 factorial also contains 997. 1001 factorial. These also contains 997. That means right from 997 factorial. Right from 997 factorial. 997 factorial say all these numbers from 997 to 1001 factorial, every number contains 1 power of 997. I require minimum 3 powers. So here there is 1, here there is 1, here there is 1, here there is 1. Yes. 997 to 101, total 5 times it is there. 5 times also contains 3 times. So what is the answer for this question? Answer for this question is 997. Answer for this question is 997. What I did, first I checked what is the largest prime number. Then I checked whether the largest prime number divides this number 3 times. It is actually getting divided 5 times. So in 5 times already 3 times will be there. In 997 factorial there is a 1 power of 997. In 998 there is 1 power. All are getting multiplied. 997 into 998 into 999. So 997 multiplied 5 times, I will get 997 power 5. But I want power 3. So answer is 997. We have checked it out whether the 997 is prime or composite depending upon the yesterday's class. Do not miss any of my classes. It's a very, very good question. Please tick mark this question. Extremely good question, sir. 22nd question. A, B, C, D and E are 5 prime numbers, not necessarily consecutive. Sum of these prime numbers is 264. A plus B plus C plus D plus E, it is 264. He said that A less than B less than C less than D less than E. Same model. Same model yesterday. Which question we discussed? I think it is 8th or 10th question. Yesterday we discussed in the first one. Let me show you that model. See. Same question yesterday, 10th question we discussed it. P1 less than P2 less than P3 till P7. P1 to 7 are prime numbers. What is the lowest from? That is an yesterday we discussed it. Same question we will discuss. Close to in prime numbers only, minimum 50 to 60 questions we will discuss. Now, this is an even number. 264 is an even number. 264 is an even number. Assume that all the numbers are odd numbers. All the numbers are odd numbers. If A, B, C, D are odd numbers, assume if all are odd numbers. If all are odd numbers, if I add all odd numbers, odd plus odd, plus odd, plus odd, plus odd. If I add 5 odd numbers, so this will become even. These even plus odd, even plus even plus odd, odd. But the right hand side is an even number. But the right hand side is an even number. That means all the 5 numbers cannot be odd numbers. One has to be an even number. What is the smallest even number? We want a less than a power 5, right? A less than b less than c less than d less. What is the smallest number? Smallest number which is an even number, which is a. Smallest number which is even and a prime number, it has to be a. A is nothing but 2. The only even number which is prime and the smallest number among the set of prime numbers is 2. Question is a power 5. So which is nothing but 2 power 5. Answer is 32. Answer is 32. I hope it is clear. Answer is 32. Smallest number which is an even number. Smallest number which is an even number, which is a value is 2. The root cause of the problem is right hand side is an even number. Root cause of the problem is right hand side is an even number. We cannot take all our odd numbers, odd plus odd plus odd plus odd. It will give me an odd number, but the right hand side is an even number. So therefore, one of them has to be an even number and one of them has to be smallest, and it has to be even. Smallest even prime number it is 2. Smallest even prime number it is 2. 22nd question. I hope it is clear. 23rd question. What is the number of natural numbers n in the range of 2 less than n less than 20? 2 less than n less than 20, such that n minus 1 factorial is not n minus 1 minute, it went behind ahead, sir. What is the number of natural numbers in the range 2 less than n less than 20 such that n minus 1 factorial is not divisible by n? First we will write an important key point. N should be in the range 2 less than n less than 20. First key point. Second key point, n minus 1 factorial. N minus 1 factorial is not divisible by n. N minus 1 factorial should not be divisible by n. The best way to solve this question is, let us take some initial values of n and try to find a pattern. Suppose if I take n value is 3. 3 minus 1 factorial, which is 2 factorial. 2 factorial is 2. 2 factorial is not divisible by 3. So 3 should come. Next one, n value 4. 4 minus 1 factorial. 4 minus 1 factorial is 3 factorial, which is 6. 6 is not divisible by 4. 4 will come. Similarly, if I take n value 5. 5 minus 1 factorial. 5 minus 1 factorial is 4 factorial, which is 24, which is not divisible by 5. 3, 4, 5 will come. If I take n value 6, 6 minus 1 factorial, which is 5 factorial. 5 factorial is 120, which is divisible by 6, which is divisible by 6. Now very important key point. Very important key point. N minus 1 factorial. N minus 1 factorial is not divisible by n. N minus 1 factorial will not be divisible by n for n greater than 6 for all prime numbers. For all prime numbers. This is a conclusion drawn from Wilson's theorem I will discuss. Extremely important point. From n greater than 6, n minus 1 factorial is never divisible by n. N minus 1 factorial is never divisible by n as long as n is a prime number if n greater than 6. So till 6 we have taken. Let me take all the prime numbers greater than 6. 7 is a prime number, 11 is a prime number, 13 is a prime number, 17 is a prime number, 19 is a prime number. So this concept till 6 we have to check one by one, and then from greater than 6 it is always n is a prime number. So totally how many values? 1, 2, 3, 4, 5. 5 values we got here. 6, 7, 8. So total, in addition to this, we will also take n value 3, 4, 5. 5 plus 3, total 8 values n will take such that n minus 1 factorial is not divisible by n. This is an important key point. N minus 1 factorial is never divisible by n as long as n is a prime number. As long as n is a prime number. As long as n is a prime number. Prime number session 2. Prime number session 2. Tomorrow onwards, tomorrow I will update the time. I think all the students who want all the live class notifications, what you can do is you can take our office number, you can do WhatsApp right now. You can just say, please send us the class notifications. We will send you all the class notifications absolutely free. 82 96 98 9020. This is our official WhatsApp business number. This mobile we will use it. Kindly say, sir, please send the class notifications. We will send you the class notification absolutely free. Absolutely free. We plan to cover at least another 36 hours of free YouTube live classes till December 31st. Sir, I want all the shortcuts from you. I want to learn it. You can send me a WhatsApp business, right, class. Just send, sir, please send us the class notification. Those who send it in the next 1 or 2 minutes, they will get the class notification absolutely free. They don't need to worry. They can send the class notification to this number. So those who want it, just send a WhatsApp message to that number. We will send you the class notifications. Just a WhatsApp message is enough. We will add you to that number and we'll send you the class notification. Kindly do that right now so that you will not miss any class notifications. Shall we go to the next problem? Kindly reply it in the live chat. Kindly send a, sir, please send a class notification to this number. We will send you all the class notifications. Next one. Kindly reply it in the live chat so that we will get into the next question. Is it clear? Is this question clear? Can I get into the next one? Next question. Everybody kindly send us the send a WhatsApp message to this number. 82, 96, 98, 90, 20. We'll send you the class notifications. 24th. Another beautiful question, sir. Each of the three friends independently think of a number which is a product of three different prime numbers. Okay. Each of three friends. There are three friends. F1, F2 and F3. There are three friends. Independently think of a number. They think of a number. For example, A. For example, B. For example, C. Which is the product of three different prime numbers. This is the product of three different prime numbers. Which is the product of three different prime numbers. Okay. Understood. This is the product of three different prime numbers. Okay. Now, which of the following could be the product of three numbers thought by them if no two persons think of the same pair of numbers? Same pair of numbers. Now, what we'll do is, first I will take an option. Suppose 121 000. 121 000. 121, it is into, it is nothing but 10 cube. Am I right? So, this is nothing but 11 square into 2 cube into 5 cube. Each of the number is nothing but a product of three different primes. 11 square into 2 cube into 5 cube. Now, can I write it as 11 into 2 into 5? All three are three different primes. Are you all with me? Here, can I write it as 11 power 1 into 2 cube into 5 cube? We got it right. Which of the following could be the product of three numbers thought by them if no two persons think of the same lines? Now, what we'll do is, first we will take 121 000. If I take 121 000, prime factorize 121 000. If I prime factorize 121 000, if I factorize 121 000, what we got it? We got it as 2 square into 5 square into 11 square. Now, if you see, now let me see, I think it is nothing but product of two different primes. I think it is not three different primes. Let me just make a change in this question. It is not three different primes. That is where my experience is saying that something is wrong. It is a product of two different primes, not three different primes. So we will delete this. We will delete this. We will delete this. Now if you see, product of two different primes. Product of two different primes. Now if you see, now listen carefully. Now you will understand very, very clearly. Now if you see, again it is 121 000, not a 000. Typist has done some small mistake. It is 121 000. It is 10 square. It is 11 square into 2 square into 5 square. Now if you see, 11 square into 2 square into 5 square. Now if you see, which of the following could be the product of three numbers? That means A into B into C is nothing but 11 square into 2 square into 5 square. Each one is thinking different. Now can I keep 2 into 5 here? Are you all with me? Can I keep 2 into 11 here? Can I keep 11 into 5 power 1 here? Because he said that there are each three friends independently think of a number which is the product of two different primes. A is thinking of a number which is a product of two different primes. Product of two different primes. No two persons think of the same pair of numbers. 121 000 is satisfying, right? This is 2 into 5 which is different from 2 into 11 which is different from 11 into 5. Now let us do 144. 144 is 2 power 4 into 3 square. Now you tell me, how will you distribute it as product of, suppose if I distribute it as 2 power 1 into 3 power 1. Remaining 2 power 4 is there. Here it will become 2 power 3 into 3 power 1. What will you write here? And this should be a product of two coprimes. Are you all with me? Suppose if it is 120. 120 is 8 into 15. 2 cube into 3 into 5. 8 into 3 into 5. Now if you see, first one could be 2 power 1 into 3 power 1. Second one could be 2 power 1 into 5 power 1. 2 square is gone. How much is remaining? 2 power 1 is remaining. But it should be product of two coprimes. So this is not possible. This is not possible. Similarly, you can do it for this one. Are you all with me? 12100. 12100 is nothing but 121 into 100. 121 is 11 square. 100 is 2 square into 5 square. Each one I can give 1 power. 2 power 1 into 5 power 1 I can give. 2 power 1 into 11 power 1 I can give 11 power 1. If I multiply all these three, 2 power 1 into 2 power 1 is 2 square, 11 into 11 is 11 square, 5 into 5 is 5 square. I hope the idea is clear. So there is a small mistake. It is not 3 prime numbers, it is 2 prime numbers. And another mistake is it is 12100. Very, very good tricky question. Very, very good tricky question. I hope this logic is clear. I hope this logic is clear. I hope this logic is clear. 24th. Right? So we have done close to 11 problems.
Press the bell icon on the YouTube app and never miss another update.